Hello everyone, welcome to Algebra 1, Lesson 76. This is called factoring the difference of two squares. Now with these types of problems, really they're very, very simple. The only challenge is just recognizing when you have this type of problem. I want you to look at each one of these. I know it's kind of hard to see, especially because there's a bit of a glare, but these are the same problems that are on the top of page 275. You have x squared minus y squared. 4p squared minus 25, m squared minus 16. For each of these problems, both of the terms are perfect squares, meaning you can find the square root of each one of those terms. And notice that one term is negative. Because one term is negative, and then both terms are perfect squares, we have a special name for this type of problem, and that would be the difference of squares. Now this type of binomial is basically like any other trinomial, except in a trinomial, for example, you would have x squared plus 2x plus 4, for example. You're missing that middle term in a difference of squares. See that? So the reason is because you have that negative in there. Let me show you with the x squared plus y squared what happened with that middle term. If I were to factor it, I have x in both sides. And I know I have y in both sides because it's y squared. But to get a negative, I know one has to be positive and one has to be negative. So then if I actually multiply these, let me write it out like this. X plus y times x minus y. X times x is x squared. X times y is positive xy. Negative y, times x is negative xy. Negative y times positive y is a negative y squared. Then when you add this together, you have a positive and a negative, so it cancels out. And you're just left with x squared minus y squared. So that's what happened to your middle term, was that it canceled out because one is positive and the other negative. So when you have a problem like this, where both terms are perfect squares and one is negative, that means you have a difference of squares. So when you have a difference of squares, it's really easy to solve. Let's look at this first one. Negative 4 plus x squared. Now, your book teaches you to go ahead and reorder it, putting the x squared in front. So we're going to do that, but you actually don't really have to. You set up your problem with your two parentheses. Because it's a difference of squares, you know that one is positive and one is negative. Then you just write the square root of each of your terms in the front, or the first term in the front of each, and the back term in the back of each. One being positive, one being negative. So the square root of x squared is x. So we have an x here and an x here. The square root of 4 is 2, so we have a positive 2, and we have a negative 2. That's it. All right, let's try the next one. 49m squared minus a squared. I'm going to set up my parentheses. One is positive, one is negative, because here is my negative, showing I have a difference of squares. So, the square root of 49m squared, well, the square root of 49 is 7. The square root of m squared is m. So I have 7m in the front of each of my parentheses. Then in the back, the square root of a squared would be a. So plus a minus a. All right, let's try another one. Negative 36a squared, plus 25y squared. Okay, I'm just going to reorder it so that my negative is in the back. Once again, you don't have to do that. You can just recognize that your first term, one is positive and one is negative, or you can reorder it like this. Okay, so I have both my parentheses set up. Square root of 25y squared. Square root of 25 is 5, and y squared is y. So that means you have 5y in the front. Then the square root of 36 is 6. Square root of a squared is a. So 5y plus 6a 5y minus 6a. How you doing? So far, so good? All right, let's try our last example, and then you'll go to your practice. Negative 36 x6 y4 plus 49a squared. For this one, I'm not going to reorder it. I'm going to show you how it works if you just go ahead and leave that negative in front, because technically you can. As long as you see that one term is negative and both of your two terms are perfect squares, then you can do this process. So I'm going to set up both of my parentheses. I'm going to make them kind of big because I see that I have a lot of factors here. So because the negative is in front, that means one of my first terms is negative, the other one is positive. But I'll be adding in both of them. All right? So the square root of 36 is 6. The square root of x to the 6th power. Remember that with exponents, when you square something, that just means that when you find the square root of an exponent, that just means you divide by 2. So you can find the square root of any even numbered exponent. So the square root of x6 would be x3. And the square root of y4, move this over, would be y2. Plus, square root of 49, to give me more space, would be 7. The square root of a squared is a. Okay, so that means I have a positive 6x3 y2 over here, plus 7a over here. Okay? That's all you got to do. All right, pause now and do your practice, top of page 276. Okay, you should be back now. Letter A, you have 8x plus 9y times 8x minus 9y. Letter B, you could have it either of these two ways. Negative 5 plus 10m times positive 5 plus 10m, or 10m minus 5 times 10m plus 5. Either way. Letter C, x squared y squared x plus 13z5 times y squared x minus 13z5. All right, that's it. Let me know if you have any questions over this lesson, and I would be happy to help you. See you in our next lesson. Bye.